This video is going to help you with hopefully numbers 5, 6, and 7 on CR 32. If I don't get through all of them on this video, well, I'll make another one, we'll see. Okay, it says, which graph shows a line where each value of y is 3 more than half of x? Okay, the key to this, in order to be able to graph, we know we want an equation in the form y equals mx plus b, because that way we'll have a slope and we'll have a y-intercept. And that'll just make it easier for us to graph it. So if we knew an equation in the form y equals mx plus b, then we'd graph and we'd see which one worked. Okay, so it says where each value of y is, okay, is means equals, so we have a y equals, this is looking good, 3, all right, more than would be addition. Okay, 3 more than, so off to the side I'm going to have a plus 3 because it says 3 more than. So this is 3 more than something. Let's find out what that something is. It says half of x. Oh, of means to multiply. So half of x would be half times x. Oh, 3 more than half x. Hey, I have it in the right form, yay. So y is 3 more than half x. Awesome. So at this point, we know our y-intercept is 3. That means when we go to graph this, the first point, just to make our lives easier, that we're going to start at is our y-intercept of 0, 3. That kind of gives us our starting point. And then we look over here and I say, oh, this is my slope. So from my starting point of 0, 3, my slope of 1/2 tells me I'll move up 1 to the right 2. So I'm just going to go ahead and graph this for myself. I think I'll just borrow one of these graphs and make it happen. I'm going to graph it down here. I probably should have put a grid off to the side here, but whatevs. So the y-intercept tells us our starting point. So we're going to start at 0, 1, 2, 3. Hey, this looks promising. So we're going to start at 0, 3. Our slope of 1/2 says go up 1, right 2. Go up 1 to the right 2, plot a point. Oh, number 4 is not the right answer. Go up 1 to the right 2, plot a point. Go up 1 to the right 2, plot a point. Go up 1 to the right 2, plot a point. And if I'm going up 1 to the right 2, did I make a mistake here? Up 1 to the right 2, up 1 to the right 2. Oh no, this isn't wrong. Up 1 to the right 2. I could also, if I'm going up 1 to the right 2, that's the same as going down 1 and to the left 2. So from here I could also go down 1, left 2. So the equation, the graph that we need to find is a graph that has a positive slope. Oh God, so ugly. Positive slope of 1/2 that has a y-intercept of 0, 3. So this is what our line should look like. Y equals 1/2 x plus 3. So I got to figure out which of these graphs matches that. I can tell you this one doesn't. Ooh, I have to tell you, I kind of like this. This is a released Regents question from Algebra 1. So those of you who are taking the one-year class next year, this could be a way that it's asked. And this is really interesting because when they did this graph, if you get so focused on up 1, right 2, you might have a hard time recognizing which graph this is. I'm going to go ahead here and I'm going to plot 0, 1, 2, 3. I'm going to plot my y-intercept. Then I am going to use my slope up 1, right 2, but then I run out of space. So going up 1 into the right 2 is totally the same as going down 1, left 2. It'll still line up. Down 1, left 2. Oops. Down 1, left 2. down 1, left 2. And you can see it creates this beautiful line here. And that's why teachers always stress to you, we need a pattern of points across the grid. If you're going up 1, right 2, please remember to get the pattern going down, it's the same as down 1, left 2, and it still creates this same beautiful straight line. And this straight line is y equals 1/2 x plus 3. I like this. I bet you I know why Mrs. Pearson chose this one for you, because she gets worried about kids who get so focused in up 1, right 2, they forget you need the pattern of points going across the page, and that's also down 1, left 2. Oh no, that's pretty cute. All right, it's 2. Let's keep moving. Let's take a look at number 6. Oh gosh, another system of equations. Of course, this is a unit you just finished. She wants the main review for this CR is the unit you just finished. It says two functions, y equals x minus 3 and 3x plus 3y equals 27 are graphed on the same set of axes. That means if we had them both in the form y equals mx plus b, this would be on the same set of axes. This is x, this is y. It means you're going to graph these lines on the same set of axes and see what happens. Which statement is true about the solution to the system? So a solution to a system, either the lines are parallel and there's no solution, the lines will cross at one point, that's the only solution, or the lines are the exact same line and all values on that line, all points on that line would be solutions. So let's just go ahead and take a look at the two functions. One of the functions is y equals x minus 3. And the other function is 3x plus 3y equals 27. Well, if I'm not given a grid to actually graph them on, I could just solve this system of equations. And the way that this system is set up, if you already have one of the equations in the form y equals x minus 3, what you can do is take that x minus 3, take what y equals, substitute that in place of the y in the other equation. This is substitution. Because that way, once I substitute x minus 3 in place of y, I'll have an equation with only x's running around. So that's what I'm going to do. I'm going to take the second equation. That first equation says what y equals x minus 3. So I'm going to substitute x minus 3 in place of y. So let me take a look at my second equation. It's 3x plus 3 times the quantity. I just have to make sure I'm going to multiply 3 by whatever y is. I know y is x minus 3, so I'm going to shove that in place of y. So then I have times the quantity x minus 3 equals your 27. So I took my second equation and in place of the y, I just put in x minus 3. I kept everything else the same. I kept the 3x the same. I kept my plus sign the same. I kept my 3 the same. I substituted in place of y my x minus 3. I kept my equal sign the same. I kept my 27 the same. So now I just have an equation just involving x, and I'm going to be able to solve for x. So let's go ahead and handle this. First thing I'm going to do is distribute this 3 to clear out my set of parentheses. So then I have 3x plus 3 times x is 3x minus 3 times 3 is 9 equals 27. 3x plus 3x, oh, that's 6x, minus 9 equals 27. In order to solve this two-step equation, I'm going to undo this subtraction first, moving all my constants to the right, all my numbers without x's to the right. I'm going to add 9 on both sides. And then I find I have 6x equals 27 plus 9 is 36. How do I get x all by itself? Well, 6 times x. How do I undo that multiplication? Division. So I'm going to divide this side by 6, and I'll divide this side by 6. And I'll get x equals, what's 36 divided by 6? X equals 6. So I now know my x value. So it appears to me as though there'll be one solution to this system of equations. The x value will be 6. Let's find the y value. I can take either original equation, substituting in x equals 6, and be able to find the y value. I'm going to be honest with you, this is the easier equation to use, that first one, y equals x minus 3. So I take 6 and I substitute it back in place of x. So y equals 6 minus 3. Y equals 3. So I know my solution is 6, 3. So I don't know exactly what these lines are going to look like, but I know these lines are going to cross somewhere over here at 6, 3. This one I can easily sketch out. So it's at -3 here. You're going to go up one, right one, up one, right one, up till you get there. I really have no idea what the other line looks like. I'd have to put it in the correct form. Oh goodness. So if I want to get a sketch for you, whatevs. So this one, I'm not going to get a sketch for you. I get so torn. So this one, 3x plus 3y equals 27. I can subtract 3x on both sides. I then would have 3y equals -3x plus 27. I could divide each piece by 3. And I would get y equals -1x plus 9. So my other line would be crossing up here at 9, 0, 9, and I'd go down one, right one, down one, right one, down one, right one. And that would be my other line. And they cross right here at 6, 3. Really, this was all the work that you needed because you weren't even given a grid, but I just wanted to show you that 6, 3 is the solution, because if we substitute it back into either original, it's actually going to be the point where they cross on the grid. Hopefully that helped. I think I'll save on number 7 to another video, only because I don't want to run out of time. My videos can't be more than 15 minutes, and obviously I'm a bit long-winded. I do hope this is helping. Days when I have to be out, I just want to make sure that you have the support you need. All right.